Hi, everybody. These are our answers for our motion final practice test. Question one, if you have a 1 kilogram object and amplify and you hit it with one force arrow, then it will accelerate by, hopefully, if everybody found this easy, the answer to this is 1 centimeter per second. This was our 1 to 1 to 1 ratio. One kilogram hit with 1 unit of force has an acceleration of 1 centimeter per second, doesn't care whether it's speeding up or slowing down or changing directions. Two, when we had the spring car spring the ball into the air, why didn't the ball stop with the car? And the answer is because the force was applied to the car, but not the ball. So the ball kept on doing what it was already doing. This is a Newton's first law demonstration. Newton's first law says things don't change what they're doing unless they get an unbalanced force. When we did the chip in the chip didn't move with the card because we flicked the card with our finger. It got the force, so it accelerated and moved. The chip did not. It didn't move until it fell into the cup. And the same thing with the ball. We didn't put the force on the ball, so it didn't change what it was doing. And number three, we just answered this. This is a demonstration of Newton's first law of motion. Number four, the ratio of mass and speed is known as momentum. Momentum is the force that moving objects can have, and it's dependent on how massive they are, how much inertia they have, and how fast they are going. Number five, you have a 0.5 kilogram object and a 4 kilogram object that are stopped, and you hit them with the same amount of force. Tell one fact about their accelerations you know will be true. Well, notice I highlighted the key part is if we hit them with the exact same amount of force. We know both of them are going to accelerate. I tell you that in the question, but we can be more precise than that. We can simply say the less massive object is going to have a greater acceleration. This was an important idea in both our box question and the final question on this practice test. So again, you have two objects hit with the same amount of force. Lighter one will have a bigger acceleration. Okay. Now here we have to complete the table and we have to put in the missing amount. We've got some click numbers, some acceleration numbers, and we've got to find out the missing thing. And you can see in two of them, I'm missing the mass and one of them, I'm missing the force. The way for me to always do these easiest is to think about what it would be if the mass, at least on these two, if the mass here was 1, what would the acceleration be? Well, 4 clicks on 1 kilogram would have an acceleration of 4. Well, this has an acceleration way less than 4, and that automatically tells us the mass of this is bigger than 1 because it didn't accelerate as much. Same idea as in question 5. So now we have to say, well, which if it was 1, it would have been 4. We had 1/4 of the acceleration. And so we need to go on the opposite of 1/4 of, and that is going to be, it's going to have 4 times the mass. If it's got 4 times the mass, it should have 1/4 the acceleration of a 1 kilogram object, and it does. Now, this one, notice that we've got a mass of 2 and an acceleration of 4. Now, remember, if this was 1 and we had acceleration of 4, this would be 4. This is more massive, so to get it to do the same thing, it's going to take more force. And since it's double the mass, it's going to need double the clicks to do the same thing as 1 kilogram object. So there is 8 on that. And then finally, again, we go back to this one. Think about what it would be if it was 1. 5 clicks would make 1 kilogram accelerate 5 centimeters a second. This one did more than that, so it's got to be lighter than this. As a matter of fact, it accelerated twice as much as a 1 kilogram one would be, which means it's got to have half the mass, 0.5 kilograms. Now, this is often the part that gives people the most trouble on the test. If you're struggling with these, go back into Amplify and do those purple and blue missions, because that's where we really spend a long time working with these different masses. And then all the questions on the table, question 6, are example of Newton's second law. We have force, mass, and acceleration. Newton's second law is just our most complicated ratio we've done because it's got 3 parts to it and not 2. But if we know any one of these, a little basic math can give us the other 2 unknowns. Okay. And finally, anytime we have two objects collide, what will be true of the force on both objects? Well, here we go to the last couple things we did. We did a lot of collisions in Amplify, and right when we'd have the collision, the little force arrows would come on to show us the force was applied, which we knew because they changed what they were doing, Newton's first law, but those arrows were always the same size, which told us that the force on both objects was exactly the same. And that also turned out to be true mathematically, because if we collided a 1 kilogram and a half kilogram object, the half kilogram object always had double the acceleration, which is only going to occur when the force is the same. So the force on both objects are going to be equal. Okay, moving to the back side of the test. Why does your arm get sore if you continually throw a ball? Well, the reason is, guys, is because while you put a force on the ball puts an equal force on your arm. This is just like collisions, even though we don't think of throwing a ball as a collision. It again goes to Newton's third law, which just says you can't put forces in any single direction. Any force one way has an equal and opposite force on the other, whether it's colliding things or you throwing a ball. So all that force you put on the ball put that force back in your arm, and your arm gets sore because of it. That's exactly why spaceships can move in space with nothing to push off of. Okay. Number 10, question 8 and 9 are example of Newton's third law. Perfect. And that just is that equal and opposites. You can't apply a force without having equal force in the other direction. Collisions or the throwing of the ball. We had the same thing when we did the longboard in class. We threw the ball in one direction and the person on the longboard went in the other because both of them got a force. They didn't have an equal acceleration because the person on the ball had a lot more inertia and also was under a lot more friction, but same idea. And then finally, we've got our final questions about these two spaceships, and I hope everybody recognized that this is the exact same question as our box question. Instead of using boxes, though, we use spaceships. Now, a couple things we need to think about going in. It said we had a collision. Well, we need to know that the force on both those spaceships was exactly the same. That's what Newton's third law says. Spaceship One's motion changed from 4 centimeters in one direction to 4 centimeters in the opposite direction, and Spaceship Two's motion changed from 7 centimeters per second down to 1 centimeters per second. So while one changed directions, the other one just slowed down. Well, we need to look at how much each accelerated. Spaceship One accelerated by 8. Okay, 4 to stop, 4 more to go in the other direction. Spaceship Two changed by 6. It just went from 7 down to 1. And that really answers 2 of our 3 questions. So which spaceship had the greater acceleration? Spaceship One, 8 centimeters per second. Which spaceship received a greater force? This is crucial. They both got the exact same amount of force. Newton's third law says they will, just like the boxes in the question. Which spaceship was least massive? Well, just think about what we said. We said they both got hit by the same force. Spaceship One had a greater acceleration than Spaceship Two, and therefore it's got to be less massive because it experienced a greater acceleration. That really is the exact same thing as we did in question 5 when we said if we hit any two objects with the same amount of force, then the less massive one will have a greater acceleration. Well, here we hit two objects, spaceships, with the same amount of force. The less massive one, Spaceship One, had a greater amount of acceleration because of that. And that's it for this practice test. Thanks for watching. Hope everybody just does great on the test.